Okay. This is a sort of unscheduled Go component lab stream. I'm going to be working on the API library that I started a bit ago, previous streams. I, by the way, pushed everything to prototypes, so pretty much all of these streams I'm working in the prototypes repository. If you want to follow along, this repository is yeah. So I actually use some of these regularly. Twitch profiles. I don't use YouTube export now that I stream to Restreamer, and that streams to both, so I don't have to archive to YouTube. I need to update this to YouTube, but obviously some of the interesting stuff and things might disappear, like this gRPC thing might disappear, and I might reorganize these things and rename things, but I'm doing most of that on stream. So what we've been working on is a RPC system on top of Quick, although it's not really specifically for Quick, but any multiplexed transport. And later today we're going to do a transport. I just realized that we're not doing any music, which I guess is fine. But I like having a little music in there. I guess I was having this problem the other night where I couldn't get it to actually work. With this new thing. Let me try recreating it. Wow. Built-in output. Okay, well, I don't know what's going on. If anybody has any tips on this, I guess I'm just gonna go without music. I'll have music. Actually, you know what I'll do? I'll go back old school and do this. Yeah, I don't know what's going on. I don't know if that's my new Scarlett device or something, but All right, back to this. We have this basic RPC stuff here. It's really pretty simple. Later we'll do some transport stuff later today, but I wanted to work on this API because I have some kind of put some thought into how I want to organize this API, as well as come up with a low-level handler API that's a little bit better than this. It actually makes it a little bit more like HTTP, net HTTP in the Go package. So kind of making this a little bit more like HTTP. We'll make a, let's see, where do we have? How did it know? Come. And so something like a responder, and then a pointer to the call. I suppose this would be an interface that I want to make here. Come on. In theory, this is not necessarily a public thing, because we would have a responder, not a response writer, because it's not actually a writer. Let's see here, but it is very similar. And then it returns a header. Let's see, maybe we would call this the response header. So destination is like the full URL, and then we can kind of break that out into the object path, which will be a string for now, and the method. Jesus. And then while we're working on this, I was going to split these out into separate interfaces. And then this could also have like proxy and other things. You get a proxy object for a path. But for now it'll just be that, and then we would have client. I don't know. There's not much to this interface. It isn't really used for much. Although it's always nice when it's interface based, because then you can like start swapping things out, but I'll try and keep it simple. Let's see, handlers. So we're kind of phasing out peer because I think it's kind of confusing having worked with that kind of API before. So this is a call. Response header. You know, that's kind of an inconsistent naming thing, but we'll figure that out. So that's our client. And then I was going to have a separate API struct, which is different from the server. So let me do that too. So So the reason for this is the server is only here to set up a listener and kind of be a traditional server, but both the client and the server can have an API, which is something that it can respond to, so providing methods and objects and stuff like that. So it has an API, and we'd kind of make it more like a traditional server API at some point, but for now we'll just kind of do this one method on it. Destinations is kind of being replaced by the API structure, but we'll come back to that. Let's see, client needs an API as well. Guess actually this being public is kind of helpful. The idea is an API can also be shared between multiple clients. So you could have multiple outgoing connections, but you want to provide a single set of handlers and responders and stuff. So we're basically getting rid of peer. Put this on API. So we have our call. These will become something else. Peer.serve. Let's see, so we can have a serve on which is great for tests too, but is this loading any better now? Okay, cool. Sometimes the server has a serve once, which is really helpful with tests and all this, but well, I guess they call it something else because they serve, I guess handle. So we'll take server. Handle session. I guess we should rename some of these other variables as well. All right, no more peer. No more listen and serve. Kind of unnecessary. So this can just become dial. So that's very straightforward. We might want to say dial with an API, but it's sort of optional. I guess though APIs because they have a map to initialize, we might need a new API. And call this export maybe. I'll get to you. This is kind of a constructor for the client. So work on handle here. This is where we would, well, I think I was thinking to hand this off to the API. The API handles channels. The mutex is actually on API. Any panics are sort of to-dos to replace later, but I suppose we would just say handle that channel. And actually we could do all of that in a go routine as opposed to doing this in a go routine. Well, let me think about that. So this is now API. We've got our listener. We don't have to do any of that. We definitely want to do this in a go routine. Because it's a loop. And we want to do this in a go routine. We want to handle multiple calls at the same time. This is going to live somewhere else. Oh, look, we're already confusing ourselves. Loop. All right, so we kind of, I've been putting this off to do this because I think it's going to live as a responder object, kind of like a response rider. I'll at least put it here. We need to fill those out. Don't need this. So I guess we'll create a responder. Which doesn't need anything more than the channel. Oh. And the header. What's our API? Here. So you can basically only call one of these. Now, arguably, you could just return an error. We don't really need that. What do you think? Simpler. Whoops. Call that E. So we can call this air. I guess I want to encode a nil. Then close. Either way, we want to close. I feel like we can do this more simply. We say now we don't have E. I think that's right. If you were to type assert and it wasn't, and this returned false, E would be nil, right? Let's just confirm that. Oh, can't say go. No. Right. And then is it nil if it's just a string? All that just to know that it's nil. Okay. But we also know that we need to do this. Questions so far? Oh, I gotta deal with this. We actually might just want to say because we have an error here that I guess we could just set up the responder then. Spawner just needs the channel and the header. I guess we'll just make a new one here. Come on, keyboard. The problem is, okay, so we need to change this to our header dot error equals E. And we encode that. So here we can actually now use the responder and say return instead of that. Let's see. Payload. And this is the call, so I'm not sure why. Oh, no. The call is up here. So we got the call. Right, this is the payload. Parameters, arguments, whatever. Maybe I should be more clear about that. Oh, how did I want to do this? So I want the handler to do the decode. So we'll just attach the channel to it. After we, what's your problem here? VS Code. So call channel equals channel. You know, honestly, we probably just want to put the decoder on it. Which later we can generalize the decoder. That's like the easiest thing to generalize. So we don't actually do this here. And we also don't handle this response. It's pretty much just like HTTP handlers, where we call serve RPC, we send the responder and the call pointer to it. Looking pretty good. I think that's everything. So we can update our demo now and try this out. Not this. Okay, what the fuck were we doing here? Okay. Let's just start over. So first thing we want to do is make an API. If it updates its shit. Export something called echo, and it'd be convenient to do the same thing where we could just do a function. So if we had a handle func. Let's do that. Let's do that. Handler func. This functions are always a pointer, so. Then we need a register export. What do they call it? Handle func. We'll call it handle. They're I guess that's more explicit docs or something. Yeah. Yep. All right, we have this. Well, since this is not the server, it's the API, we could call this serve. So that'll let us basically do this. Responder is a Q RPC responder. And this is a Q RPC call. this is handle func, right? Is that what we called it? What's the problem? Responder. So first we'll do a log print line echo called, and we're going to get the payload ourselves. So that is C dot decode, right? It's just not updating its whatever for some reason. I did do this, right? Oh, maybe I didn't. I did not. That's all. Right. It doesn't know any better. So here's why it's cool is I can actually specify the message, which is an echo message, and then get that loaded into that message. If there's a decode error, we could actually just respond with that error. That's kind of cool. Seems funnily redundant. Well, I guess we don't return a value, so we can't do that. Extensions, get out of here. Well, I didn't mean that. Okay. So we can modify the message. We can say, oh, it's not a request anymore. It's now sent in the response or whatever. We're modifying it just as a demo. And then we can just return that. All right. So this new API lets us share this API object with both our client and a server. So we can create a server, which I guess we have to do qRPC server. Yeah, no, it doesn't like that. Oh. Listen and serve on our adder, which is global. Oh, it looks like we could specify the API here. We'll do that. And then we'll do a client. Actually, we can do qRPC dial adder, and we are going to use that. Now that we have a client, we can call. I guess we're going to call that. So let's see. What do we call it? Echo message. What is our message? And request is true. And then we'll where is it? I'm not looking. There's the request. Create an object for the response. We call it echo. We pass our this, and then we pass a reference to this. If there was an error, just panic. Otherwise, we'll do this. And this should give us kind of the equivalent of what we had before. Nope. That doesn't make sense. Is that the first reference to? Listen and serve API. Yes, interesting. Yeah, we don't set it. What is this doing here? We just set it. We don't actually set it on the server. That's silly. So if it's not nil, there is something that I want to do here, which is then either way, if this API is nil, I think this is what I wanted. So this is always going to override, which is just kind of a convenience thing. I'm not sure how the HTTP library works, but anyway, this should work now. Let's see. So that's as far as we got before with the old API. As you can imagine, this is a little bit nicer because we can share this API with our client and the server. Client and server objects are there instead of appear, which is kind of a nice distinction. And when we want to do a client from a server, we should be able to so now we want to get this bidirectional. Trying to think. It's funny. If we put a caller on the call that implements the caller interface, it's sort of a semantic alignment, right? Because you're dealing with a call. Who's the caller? So it's got a caller property, that's the other side. But the caller also happens to be a caller interface, which means it has a call method. That's funny. Let's do that. We still haven't done this, but we don't really need them. Right, caller call, client, where do we set that up? Here. Okay, this is interesting. We have a channel. I guess we would just create a client. Need a session though. Does transport give us a session reference? We don't. We can put it in the context. You can also just pass it in. we haven't gotten to how the API of a client serves yet, so I'm going to leave that nil. But at least now there is a caller call object. So in theory, we could, in our demo, maybe after we return, we do kind of the same. Hello server. Hello client. Caller call. This would fail because our client is not set up to respond to channels open to it. So I need to come up with a something like serve API. Let's see, what does our server do? Handle. If we call this something like serve API, and we could put that on both client and server. Pretty much the same thing. Except we have the session and the API in theory. Okay, so we just call this in a Go routine when we want the client to actually serve its API. We could do that immediately after here. So if this works, we should see this echo output twice. The only thing is we didn't wait for the server to get its response. Let's see, what do you think the best way to do that is? Let's see, server. Well, I guess there's a problem in that if the server calls the client's echo, it'll just go back and forth forever, right? So having some way to know that this API is one side or the other. In this particular case, that's helpful. I'm just not sure if you want to actually design things like that. Because how often do you have something like this where they call each other? I mean, we could just create two different echoes. It's more realistic, but it kind of does gets in the way of conveying this, but let's just get this working. Echo client. Where all it does is echo. And then we have echo server, which will echo and then call echo client. This won't prevent it from finishing before it gets the response on the other end, but now we could do something silly like so we called echo server with hello server. Before we even get the response back, which we get the response hello server, the request hello client is sent out. Hello client is called, so the client is serving its RPC stuff, and then yeah, so that's working. Bidirectional RPC. Over quick. What else do I want to do? Let's see, I did this. Any questions, comments? Feel free to chat. So now the idea is this is kind of the low-level way of setting up handlers, but we'd like to create a way to generate a handler from a function like this. Echo. Let's see. I guess we do it in order. This is a little different though. We could take in an echo message. That should work as well. But you should also be able to return a value. Potentially an error. Call this simple echo because it's just a string. In which case we just do that. So now our goal is to build a wrapper that will do some reflection and let us basically register this function. Which will take longer than 30 minutes, but you can at least plan it out. So I kind of thought it would be something like this. What we called it. simple echo. And then we create something like RPC. Something like this. Later on, we'll have kind of a more in-depth API for managing the object hierarchy. But for now, we're just kind of treating it like a simple, you know, method namespace type thing. And in that case, this API might change, but at least this would be a good like foundation. This is like a really good kind of reusable, you know, and sort of componentized way to do this. We just have to implement this one function. And then later on, we could create an export that takes an object. Let's see how that works. So it's either export taking an object or export methods, right? And it would export the public methods on there. So let's try and figure this out. I think for the most part, we're just going to create a handler func that wraps calling it and figures out how to take the input that we're given and convert it into the arguments and take the response. So we actually have some code for that. Actually, I wonder if we could do this in 20 minutes. So in theory, we have no idea what this type is. We could just do a map. Hammy85, thank you. Is that a birth date? I think, because if it is, that's my birth date. We could actually do this in a way where we support yeah, I don't know if I want to do that. Hammy, welcome. Are you Go software programmer? Are you interested in Go? What brings you here? I'm just gonna do key value stuff because panic. Anytime I write panic error, it means I'm gonna figure out how to do error handling later. Easy to find them and gives you an idea of how often you hit it. Oh, cool. Well, hopefully this is helpful. There's actually some great beginner stuff on YouTube for Go. Everything I do is sort of real world stuff. It's maybe a little bit more advanced, so hopefully that's helpful to watch. Invoke the function. But then we also want to look for an error type in its return values. And then also, let's see, could we do that? I guess. Right, and then we would just say our return, whatever that is. Duplex. An old version of Duplex did a lot of this reflection stuff. But it's specific to methods, so I might want to just look at the reflect docs and figure it out again. It's almost lunchtime. Reflect. Go has a great reflect package. Okay. So I think we want value of. No, we want type of. And then type. All methods applied. Which is the number of exported methods in the types method set. How it returns the type. Okay, so we would use that. Return. Right, so these are helpful. Those are the ones we want. Is this as well as this one? We're gonna get a name, I think. Where's the type's name? Do we not get the names of the arguments? And I'll want to support variadic. Type's name. Really quick. Golang reflect function argument name. Did someone do this already? Method by name, get. I don't want that. I want a function. This is garbage. Oh boy, maybe we can't do this. Good point. So, yeah, I guess if we want to do it by name, you'd have to take an object. So we can support... oh, what? That's interesting. So we'll just do positional for now. Which means God damn it. Hey, AJ. How's it going? You right, Golang? Well, that's good. I think you'd like it. It's a great middle ground. For the C types in the higher level. Yeah. Well, actually, I'm about to wrap up for today. I'm going to do some more streaming later, but later today, first I'm actually going to work on a game for 2 hours in a couple hours, and then after that I'm going to come back to this and do some more transport stuff, implementing some other transports other than Quick for this system. Yeah, I guess that's something. See, there's some decent libraries that you can use to get Go routine-like stuff. Was it libmill? Yeah, libmill. Yeah, it's pretty cool. I've never used it. But I follow the guy who does this. He was one of the developers of ZeroMQ. So, yes. I mean, I imagine it's doing, an event loop. So it's all single threaded. I don't know if it goes and does what Go will do, which is multiplex them over several threads, but I'm sure most of it is basically single-threaded. Anyway, that's worth checking out. So I guess I'm mostly dealing with this. Yeah, this part's gonna be a little bit tricky, so I'm not gonna be able to do it in the next 4 minutes, but kind of leave it at this. The later day when I come back to this, I'm not gonna be working on this. I'm gonna be working on transport stuff, so maybe tomorrow or something we'll come back to this. But pretty excited. This is good progress. And actually, I should do a recap. So let me think. What did we do today? Did I push this? It'd be helpful if my repository was a little out of date so I could reference the old version. Okay. All right, let's do this recap. Okay, so today we're working on QRPC, which is just kind of a naming scheme for this RPC system, iteration of mini RPC systems that I've done. This one is sort of the latest version, and its killer feature is bidirectional calling so that it can support callbacks, which is something that gRPC does not support. So last stream on this project, we actually got a prototype in here. First, we wrote a transport abstraction and then did a quick implementation for that. So this can actually support any transport that supports multiplexing, which makes that really easy. QRPC itself was very simple because it's just now that you have a virtual stream or a channel for every call, you can just write a couple of objects, marshaled objects to it, and read them off. So what we do is when we send the request, we have an object that sort of represents the header of the request or the call, with the destination, which represents the method that you're calling. And then we serialize the payload, which represents the arguments. Then the server is just going to respond with a response object that has an error, if there was an error. And if there's a value, then it provides a value. So then you can kind of demarshal that into any structure that you want. This is using message pack. We created, this isn't that important, but kind of important today, we were working with this peer interface, which is something I keep using because, again, it's bidirectional. So a client can act as a server and a server can act as a client. So we have a peer that lets you register methods that can be called as well as call methods on the other end. And so you get a peer by either connecting to a server, whatever that is, which we can get from listen and serve, or we can dial a peer. We implement those things. The interesting things is call, which is very simple because, like I said, all we're doing is encoding the request and whatever your arguments are, then decoding the response header and whatever that value is. And if there was an error in the response header, then we return that. On the server side, it's a very simple server where we decode the request. We see if we have that handler registered. If we do, then we decode the payload and we pass it to the handler, and then we send the response, which is mostly just checking to see whether there was an error or value. So this is what we had the other day. I decided to spend some time on this API and came up with something I think is a bit easier, not just easier to wrap your head around, and has kind of good properties for creating middleware and stuff like this, kind of borrowing the ideas of the way the NetHTTP library works. So if you can think in parallel to the NetHTTP library, our request here is a call. This will kind of come back to that. Then we have the response that we send back. And again, this is mostly the same structure as before. We're just calling them different things. And so our response is now the response header. But we have this new interface called a responder, and this is kind of like the equivalent of a response writer. And so we can get the header object itself, and so if this has more complex stuff later on, you can get access to that inside your handler, or you can just call return. And return, it's kind of assumed that if you return an error, it will then populate that as an error. We then, instead of our kind of this destination stuff, which was, a handler is a function that takes a empty interface request and returns an empty interface value and an error. We had a destination that wraps that up, so you have a path. That was kind of a last minute thrown together thing. We're kind of building up a new system here where very much like an HTTP handler, we have a handler interface with a serve RPC method. So this looks very similar, right? We have a responder, and then we have a pointer to the call structure. We also have a handler func, which just like HTTP is a function version of that. So you can more easily just define a function and then pass that as a handler. We got rid of the peer interface and went with something that made more of a distinction between client and server for a couple of reasons, but part of this is so we have this caller interface, and so what you get on the server side when you want to call back on a connection is not necessarily a client. It's a caller. It's something you can call on, and potentially other things. And instead of a peer, we have now an actual client, because this is more clearly going to be used in situations where you're connecting out. So we have a much more traditional dial, and it gives you a client. Clients can have an API, and so this is kind of one of the new ways to create a way of defining the methods that are exported that can be shared between a client and a server, or across multiple clients even. So we separate the concept of the functions that you're serving up into this API. So that makes client very simple. Client implements caller, so once you have a client you can call, and this call looks pretty identical to what we had yesterday. We also have a serve API, which is something that you would call in a Go routine to basically listen on your connection, listening for channels. Yeah, I'll talk about that in a moment. So serve API you call in a Go routine, and then it will basically listen for new channels and then call serve on the API, which will then handle that. Then I'm going to skip ahead to this server because the server is actually very simple. A server is a struct with an API, and right now it just has a listen and serve. You can imagine this would have other listen and serve and stuff like that, like most other servers, and so that can all be contained to this server struct. So anytime you want to listen on a port or whatever, you'd create a server. which is ultimately just going to accept connections and call serve API. Serve API takes a session, and very similarly to the client serve API, will call serve on whatever API. So when you set up a server, you also give it an API. So let's look at API. API is basically a place where you can register handlers. Right now, that's all it is. Right now, it basically has very similar to like a serve mux in HTTP. You can do handle and pass it a handler, or you can do handle func and pass it a function. The thing that is being called by either the client or the server serve API is this serve, which takes a session and a channel. And this is where we start implementing the kind of protocol where we decode to create a call object, and we would set up other, parse it and populate it a little bit more. We take our decoder that we set up and we attach it there because that's going to be used mostly for the calls decode method. So you get past the call and you can decode yourself what the structured object that's passed as an argument yourself. We also set up a caller, which right now is actually a client with no API, just pointing to the session of this connection. So this makes it easy. So in your handler, you can then say call caller and then say call to basically call back to something on the other end. So we do some more prep. We set up a response header, and we create a responder, which we talked about before in implementation. All it is a channel and a header, and it has these two methods, right? Header that returns the header, or return, which basically just checks to see if you're returning an error, set the error on the header, and then encode the response header and then whatever the value was. And then close the connection because you're done. Not the connection, the channel. So that is ultimately passed to the handler that we look up, which if we don't look it up, we actually just return an error that says handler does not exist. Otherwise, we say handler serve RPC, pass the responder, and the call. So you can see that structurally this is very similar to HTTP, which I think is very helpful for people in kind of understanding, being kind of familiar with it, but it also introduces similar properties of the HTTP. For example, we can create middleware that wraps. All we have to do is whatever handler, we can create a handler that will then do modifications to the call, maybe produce a new responder that does something else when you return. And so that opens up the possibility of middleware. And this is also set up in a way that APIs are independent from the client and the server because they're shared, and so that kind of makes sense. Yeah, I think this is both a very well kind of decomposed API and very familiar. So I like where this is heading. We also wrote a little demo that kind of shows this example, ignoring this stuff, which is kind of what we're working on next. But you would just create a new API. You would create some functions for it. In this case, this is how you create handlers. The idea is later on we can create higher level wrappers that can export and expose, for example, a function that looks like this, or an object and all its methods. So that's coming up next. So here's some more functions. We create a server. We say go listen and serve in the background with that API. Then we do a dial and we connect to that server with a client that's using the same API, so they actually both can call both methods from either side. In order for the client to serve and respond to those, we need to serve the API, so we do that. And then this is the call where we set up a message, we print it out, we set up the response object to have it decoded into, and we do the call, and then we have it. So I'm pretty happy with this API. So real quick before I close out, interfaces are basically like Golang's way of doing object-oriented would do by making sure the class inherited or implemented the proper methods. Yep. Yeah, I mean, it's I think a lot better than other object-oriented. It's a very lightweight system. Basically, any type that you make, because you can create types, any types can have methods on it. You can create a type that is an int and then add methods to it. And when something has methods, it can implement an interface. It doesn't have to say that it implements an interface, it just has to have the same signature. So it sort of automatically, everything that implements an interface automatically has the interface. So now you can create code that takes or returns objects that implement an interface as opposed to that implementation. So interface driven stuff is super, super great in Go. Create custom class to be passed as objects. Right, and so it's also very helpful because it lets you wrap stuff. And so this is, like I said, how a lot of the middleware stuff works in NetHTTP. For example, just to kind of point that out, because this is a good question, a really great feature of Go. Because the handler is given a response writer, which is an interface, not a particular struct like request is. Because this is an interface, you can create, you can basically wrap response writers that do extra things when you use them, and you can pretty easily just create a new implementation that implements those methods and then pass that to whatever was expecting a response writer. Your new type can even embed the original response writer in it, and all of its methods will automatically be exposed in yours. So you can just kind of overwrite the ones that you want. So it's subtly different in terms of object-oriented programming, but I think it's a much better way of thinking about it. Anyway, so that's it. I gotta go. Thanks everybody for watching and hanging out and asking questions. This project, yes, this project is on my GitHub. Basically, everything I'm working on these days is in this repository. So almost every stream is going to be working on this repository. All of these things might seem unrelated, but they're actually all part of a much bigger project. So some of these are experiments that'll go away. Some of these might spin off into separate projects, but for now, this is what I'm working in. If you want to, I'll push this code so that it's available, and then yeah, definitely open to collaborations and ideas and stuff. What else? If you're check my Twitch events to see scheduled events. I have some pretty regular streams, but I also do these kind of one-off unscheduled streams for little projects that I can't wait for. So when I have some extra time. So anyway, join me if you're watching on YouTube. Definitely subscribe, and you'll get notifications for all of these videos and streams. So. All right, AJ, great to meet you. Definitely follow me on Twitter or subscribe on YouTube. And that goes for everybody else as well. Cool, thank you. All right.